What is up, everybody? Tom McGraw here with another Learn Rust live stream. Thank you for joining in to watch. Today, we're going to be continuing with our Rust track on exorcism.io. Now, before we hop in, the usual plugs. If you are not caught up, we've been going through Exorcism. It's an awesome online tutorial. We're going to continue that today. We're going to do one more exercise. It'll be a shorter one today, but it'll be a fun one. So you can catch up on YouTube. Just go to youtube.com/TomandGirl, see it up there, and check it out. We have all of the Rust Exorcism track videos. We are on part 6 today, so that's awesome. And then, of course, you have the one-off videos to check out. If you are joining for the first time, you got to check out this long Rust series. We went through the entire Rust book. Really cool, really fun. But today it's all about Exorcism. It's also a great place to start. So let's go ahead and see what we're going to be doing. Also, before we do that, real quick, shout out to everyone leaving the comments. It's been amazing. It's like I feel like I'm on this adventure with a bunch of people, and that's why I did this. So want to keep it up. Put some comments in YouTube if you're not in the live chat. If you are joining us live, it's usually Tuesday nights, 9 p.m. to 11 p.m. And that's at twitch.tv/TomMcGraw. It should be easy to find. But yeah, join us live. Put some stuff in the chat. You can interact. You'll hear, obviously, if you've been watching the videos, you hear me interacting with folks in the chat. It's been a little quiet, but that's cool. Ultimately, it's going up on YouTube, and you can watch it at your own pace, watch it at 2x speed. You don't have to deal with me live. It's probably the better way to do it, honestly. But all right, check it out. Let's see how far we've come. So we've done functions, floating point numbers. We did the enums, external crates, vector macros. We did the breadth, and now we're going to go deep into these because there's some exercises that they tie to different individual things that we need to learn, right, in the syllabus, like concepts, right? So we have all these different concepts. So today we're going to dive in back into the enums concept here with this sublist exercise. So here's where we're going to get started. Let me just make myself a little smaller so you can see kind of what's going on here. So I'm going to copy this here. In case you can't see, there's a copy button here where I can copy. I'm going to paste that into my terminal, and that will pull down the latest exercise. So let's go over to my terminal here, paste that in there. And what we'll do is we'll just jump in there. So just hop into Exorcism, Rust, Sublist, and I'll go ahead and use VS Code to open that up. Now, while that's loading, I'm going to hop back over and kind of read the instructions. So what are we going to be doing today? Let's find out. So today is going to be inside that basic enums concept. So we know we'll be dealing with enums, but we don't know what the exercise is yet. So let's check it out. And it also has a difficulty. Now, do not let the difficulty deter you. What I've found out from some of the other tracks is they can be challenging, but the whole idea here, this isn't a Souls game, right? The whole idea is not so that you fail, and it's eventually you get it and you feel like a master. It's so that you can try it out. And if you don't understand it or you can't complete it, that's totally fine. Google it, look it up, you can challenge yourself. But when you start to get into that point where you can't figure something out and you're losing motivation, you want to avoid that, right? Because that's what's going to kill your momentum. So just look at the guide. If you get stuck, do that. And now I haven't tried this yet, so I'm not sure if that's going to be the case here. Probably not. Medium, I'm sure we can handle it. But then there's harder ones. But basically, the point here is not to cheat and look up the answer. It's if you get stuck and you feel like you can't continue, don't let that kill your momentum. You're here to learn a language. Maybe you're here to be challenged. That's great. But if you want to learn a language, just do it however works for you. So don't get intimidated by that. And hey, you have a community of Rust stations now in the YouTube comments you can reach out to. But yeah, let me know what you think. So just wanted to do that, preface that a little bit. So don't get deterred. You can do it. And if you can't, there's plenty of people who can help you. Okay, so here's the instructions for this one. Given 2 lists, determine if the first list is contained within the second list. Okay, so we're doing sets, like supersets, right? Superset is a set of things that contains, if something is a superset of something, right, it can contain that thing within it. So this is lists, so we're doing sublists, superlists. So let's see. So given 2 lists, determine if the first list is contained within the second list. If the second list is contained within the first list, if both lists are contained within each other, or if none of them are true. Okay, so a few different scenarios. First list is contained within the second list. That's, you have their first list, second list, it's contained in. Second list is contained within the first list. both lists are contained within each other, meaning they're equal. That's what that means, right? Or none of these are true. They're not equal at all, right? Specifically, a list A is a sublist of B if by dropping 0 or more elements from the front of B or 0 or more elements from the back of B, you get a list that's completely equal to A. So 1, 2, 3, 1, 2, 3, 4, 5, 3, 4, 5, 1, 2, 3, 4, 5. So dropping elements, right? You can drop elements and you'll see if I drop, let's take a look at this one. This one, if we look at the front, they're just equal. Meaning if I drop these elements from the back, 5 and 4, we have the same list. In this one, if I drop 1 and 2 from the front, we have a list. So we know that this A list is a sublist of B. Here, A is also a sublist of B. We have to drop a few elements off the front, right? We have to drop the 1 off. Sorry, let me highlight it for you. We have to drop the 1 off, we have to drop the 2 off, and we'd also have to drop the 5 off. But still, it is a sublist. Here, they're equal. Here, we have a scenario where B is a sublist of A, which means that A is a superlist of B, right? So superlist is the opposite. So you could say for these ones that B is a superlist of A, right? So here we can see that A is a superlist of B because by dropping 1 and 5, you can get list B. Here you can see that it is neither a superlist nor a sublist. And that's because 1, 2, 4 is not contained in order here. So it has to be in order, right? You have to be able to just get that list by dropping aspects of the other list. So I'm not sure what part of this is going to deal with enums. Maybe they're expecting us to use an enum to solve it. I guess we'll see. Maybe sublist, superlist is probably going to be the enum that we deal with. Let's see. So I've pulled that up here and I have it in VS Code. And so again, you know me, you've been watching, you're like, old Tom's going to go right to the tests as usual. Yeah, we are. We're going to go right to the tests as usual because we're going to do it TDD style. Test-driven development. That's why I love exorcism, right? It's like the one place I can really do it. So let's take a look. Here are our tests. So before we even jump in, we're going to go ahead and run the test. So let me get out of your way a little bit. And let's run the test. So we're going to just do cargo test. We're going to leverage cargo. It's beautiful. And our test fails. And that's fine. And it fails because no, it's not implemented. That's what we expect. Okay, so let's take a look at what the first test is expecting. So the first test is called empty equals empty, meaning we have an empty list V, right? And again, we're not dealing with vectors here, it's just lists. So we're just dealing with just a regular list, not a vector. We're not adding to it, right? We just have a fixed list. And so it's just checking if V equals V because it's both empty. So let's write our code, solve this, get this test to pass, and move on. And all our code needs to do to be able to pass this is pretty simple, right? So let's pull up the code. So here is the code. And I can even pull the test up over here. There it is. Move that over here for now, just for now. And let's see what we have here. Actually, let me get rid of that so you can see the whole thing here. So hopefully that's not too small, right? That's good, right? Let's go with that. Otherwise it's too big. Okay, so here's the enum. Okay, this is what I thought. So our enum is the comparison. And so if it's equal, we'll return comparison equal. If it's a sublist, again, if A is a sublist of B, we'll return sublist. If B is a sublist of A, that means A is a superlist. And if they're not equal, they're just not equal. So in this case, we just need to test that empty is equal to empty. So let's do it. What we can do is we can just check if first list dot len, right? We can get the length equals 0, or sorry, I'm in JavaScript land. Whoops, equals 0, and second list dot len equals 0. Then we're going to return equal, and that's just comparison equal. And of course, it's going to complain because we don't handle the other cases. So what we'll do is we'll just handle the other cases by returning comparison unequal. And let's see, what does this say? Need to return it. Duh. Simple. And this is just complaining with the squiggly because it's saying, hey, you don't need those parentheses. You're not in JavaScript anymore. You don't need those. All right, fair enough. All right, so let's go ahead and run our tests. And great, it passes. Now, does our function do what it really needs to do? No, but the test passes. We'll refactor later, right? Let's enable another test. So let's open up our tests. And so I'm going to enable this one now. Test empty is a sublist of anything. Interesting. So if A is empty, right, it is definitely a sublist of B. That's great. And probably the reverse is true, right? Like if B is empty, it is a sublist of A, making A a superlist. So let's handle both those cases. So I'm going to go ahead and see here, we have that test here. If test anything is a superlist of empty. So you can see here empty. So let's just run those two for now. We'll just run them, show that they fail. Yep, they fail because it's expecting superlist here and sublist here, but I'm just returning unequal. So let's just code it. I know this isn't going to be slick, but again, we're using TTD. Let's just get the test to pass. So let's do else if, let's check just for the first one in this case, first list.len equals 0. So this is basically saying if both are 0, okay, if they're both not 0, if the first one's 0 length, then we return that it's a sublist. Comparison sublist. Else if second list equals .len equals 0, then we're dealing with a superlist. Because at this point we know that first list is greater than 0. Great. Oh, and it's just telling me again, yo, JavaScript dude, get your parentheses out of here, clean that up. Great. Otherwise, return unequal. So let's go ahead and clear this and run test. Great. So those tests pass. Again, this code isn't that fantastic, but we're going to clean it up. We have the test now that we can rely on. We code, make the test pass, refactor. So right away, I'm trying to see, is there anything out of this that I can refactor right here before we start adding complexity? Well, actually, there is something. So because lists can actually be directly compared. So a list of elements T that have partial equality, we can actually just compare those lists directly. So we can actually figure out equality if we just compare the list, if we just check if it's equal to the other list. Let me show you what I mean by that. I'm going to print something. So I'm going to create a list. Let list A equal 1, 2, 3, right? Let list B equal 1, 2, 3. And again, I didn't say let list B equal list A. I'm actually specifically just declaring them literally here, right? And so now I'm going to print and we'll print list A equal list B question mark, and then we'll print the value, and here we'll do list A equal list B. And let's go ahead and run this. Oh, I forgot. In order for the print to actually show up, I need to make sure I'm not capturing it. So I believe that's cargo test, no capture. There we go. Check it out. List A equals list B. True. So we can use that. So that what can we do with that? Well, let's get rid of that. We're good. We can change this to just compare the list directly. So we can do if first list equals second list. Now we'll know if they're equal. Let's run it to make sure that our code still works. And perfect, it does. So it's a little bit simpler, the code, but also it catches all the other scenarios. If they both just have 1, if they both just have 2 elements and they're the same, it's going to capture all the equality cases. So our equality is finished. We're done there. That's awesome. Okay. Now, test 1 is not test 2. So we can do a few things here to solve for this. We can check that if they have the same length, but they're not equal, we can return unequal explicitly. Now, this might pass because we're doing unequal down here in all the other cases, right? So if it doesn't meet these cases, it goes to unequal. So it may very well be that our test will pass as is, and it does. So we can leave it, or we can try to code to this. But where it's going to get really interesting is actually when we start dealing with real lists, right? So in this case, we can add a condition, and we can say, for this case, the logic would be something like else if second list dot len equals equals first list dot len and second list does not equal first list. Now you may be asking, well, isn't it unequal if they don't equal each other? But no, because remember, we're checking for sublists, right? And so one might have a bigger length. We're checking first that they have an explicit length, and then we're checking that if they're the same length but they're not equal, then we know they're unequal, right? And so we can just do else if, and we can do comparison unequal. And then of course this is still going to pass because it might fall back here, but let's just run it, and then what we'll do is we'll change that and see if it still passes. Good, so that passes, but let's change this to equal and see that everything still passes. Cool. But again, we have this if else. We're going to refactor in a second. This is checking a larger list, so for equality, so let's try that. I think that should work because our first conditional is just checking for the list, right? The comparison, so let's run that. Awesome. And here's where we actually get into the actual problem, right? So sublist 1, 2, 3. So here's where we actually need to figure stuff out, and we're going to refactor our code. So let's think about this. How do we want to do this? Well, usually when I go into something like this, whenever I'm doing exercise, I always tend to like lean towards like, oh, the algorithm behind it, right? You have to figure out which one's bigger, and then you chop off the front and see if it starts with that, or maybe I can look to see if I can just figure out if a list has a contains, right? So first I would look at the list API. Then there's another thing I would do. Just thinking about like if I wasn't in Rust, if I was in another language, how did I do this? The clear thing that stands out is I just convert both lists to a string, and then I can just use string contains, right? Convert both lists to a string and see if one contains the other. But let's first see if we can just do that with lists. That'd be easier, right? So what I'll do is I'll do the Rust list. We'll go to the docs. So we'll go to collections. In this case, it's just like a vector. So we didn't declare a vector. We're just declaring just a boring list, right? But we should be able to see. Let's see, Rust list. Actually, sorry, array is what we want. Array, that's what we're dealing with, is arrays. So let's see, we have let's see. Array. Each ref, zip, try map, copy. No, this isn't what I want. No, we actually aren't dealing with this. Let's see. So what I'll search is Rust array contains. No, I don't want the answer. Oh, this is what I want. Yeah, why is it not here? Let's see. Do we have contains? Let me see. Okay, this is the primitive type array. Let me go back up to my docs here. No, that's not what we want. Let's, 'cause, 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 Slice. Ah, this is what we want. Slice. Yes. Okay. So we're not dealing with a string slice in this case, though. It's just called a slice. Got it. Okay, so we're dealing with a slice. So let's see. Do we have anything with contains? Contains. Returns true if the slice contains an element with the given value. Okay, so this just looks for a single value. So we can't actually check if it contains a whole thing. Let's see. What else do we have? We have chunks. That's to get us some chunks. That could be cool. What else do we have? Rotate left, R split. Sort. Swap with. Ooh. Starts with. What's that? Starts with. Turns true if needle is a prefix of the slice. Ah, so this is actually good, right? Prefix. And there's ends with. So we could use this, right? We could say, does it start with this? If so. And then we can chop off things. But again, we could do that. I think the easy route, though, would be to just convert to a string and use .contains. Because I know string contains will work. But wait, let's see. Is there a way to... There might be a different option. Oh, this is cool. Strip prefix, strip suffix, so it'll give you the thing if it exists. What's binary search do? Looks up a series of 4 elements. The first is found with the uniquely... Okay. Wait, let's see what this is. Binary search. Binary search is this sorted slice for a given element. Okay, so for a given element. So we need more than an element. Examples. Looks up a series of 4 elements. The first is found with a uniquely determined position. The second or third are not found. The fourth could match any position. 13, 4. Huh. Binary search by. Let's see. What else? 2vec in, no. Let's see. Anything else that we could just use right out the box? Split, no. We want like contain. Oh, join. Well, that's what we can use probably to convert it to a string. So that's what we'll do. That's what we'll try. Let's try that because there might be a way to do it. I bet when we look at other folks' solutions, someone will find a clever way. But let's do it the way I'm comfortable with or the way I'm thinking about it. Convert it to a string because string contains we know works. Okay, so how do we do that? Well, so first let's leave our code here. Let me move this test out of the way. So let's leave this code because this code works. But let's actually handle this part down here. And then we'll refactor because this stuff we probably won't need. But let's leave that there. And then here we'll do the convert to strings and simply use .contains. So how do we convert to a string? So join, so we saw join here. So what join will do is it'll take elements of the slice and join them on a, and here's the string. But unfortunately, because we have integers, we can't just use .join. We'll have to convert each element to a string, which is unfortunate, but well. All right, so let's do it. So what we're going to do is we are going to convert it to a string. So to do that, let's call it first list string. Set it equal to first list. We're going to convert it to an iterator so we can iterate over it. We're going to map so we get a new list, converting each one to a string. So let's give it an anonymous function, x, and we're going to do x.toString. Let's see if this is not working because, let's see. ToString exists for the reference t, but its trait bounds were not satisfied. The following trait bounds were not satisfied. Standard format display. That's because t is a generic we specified up here, and we've only specified that it has to have partial equality. What this is saying is to be able to convert it to string, it needs to also have the trait display. So we can add that. First, we learned that in the book, right? So first what we can do is we're going to import it. Import standard format display. Oh, not import. What language? JavaScript, boy. Get out of here. So there we go, display. And then to add it here, we use, I think it was the plus. Yes, okay. Now toString should work, great. And what we're gonna do is we now have a iterator of strings. We just simply need to collect them together, and then you'll have a single string. And so if we look at the type of this, it should be a string. Oh, it's unknown. Okay, we can fix that. To tell it what type it is, we can basically say, I believe that, and now it'll know it's a string. Cool. All right, let's do the same thing with the second list. Second list string, same thing here. Second list, great. And now what we'll do is we'll just say if, no parentheses, come on, Tom. If it contains second list string, and we might have to borrow here, maybe not. So if it contains the second list string, what we'll do is we will return comparison Superlist. Otherwise, we'll return, otherwise else if second list dot contains first list string will return sublist. Whoa, what's going on? And it's complaining because we still have to have another condition. So for now, what we'll just do is we'll say return unequal, right? Compare it, because if it gets down here, we're just not equal. And let's see, I think it might have to borrow. Yeah, so, okay, so it's expecting something to commutate. So it says just consider borrowing here, right? So we will have to borrow, so that's okay. It tells us what to do. We'll just listen and do that. All right, that should do it. Let's pop over to our tests. Let's enable some of them here. Let's go down, 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 down here. Undo that. Sublist in the middle, we should be able to handle that. Sublist at the end, we should be handling that. That should work. Sublist early in huge list, doesn't matter the size, we're handling it. Of course, it's gonna be long, right? It's order n. So, because we're iterating over each list, so this might not be the most efficient, right? We're iterating, converting to strings, so it might not be the fastest, but you know, we're still dealing with order n, even though it's 2n. So get rid of this. Superlist at the start doesn't matter. Superlist in the middle, we should be handling that. Should handle that. Should handle that as well. Recurring value sublist doesn't matter. We should be handling it. All right, let's try running it. We did it. But our code looks like not great. I don't want to say crap, but I don't not either, you know? We can clean it up. We have our tester line. So again, we have our tests, right? Clear. So let's refactor. So let's see what we're doing. So we know that this is going to handle, well, we're handling equality here, and this will handle everything other than equality, right? It'll handle if it's 0, because no string, right, is not contained in, you can't say empty string is contained in a string, right? And a string can't contain empty, or I guess it can, right? Which it'll actually satisfy these. So this we can leave. I think this is going to stick around, this case here. That's fine. Exit early. If they're equal, exit early. I don't think we need to check this, because I think our string will capture this, right? Empty string, if I have a string, it contains an empty string, just like lists. So we can actually get rid of this. We can get rid of this. If they're the same length, but they're not equal, we might need that, but I don't think we need that either. I think we really just need to check equality, and then down here, We're checking if it's a superlist or a sublist. And if it's not, then we know it's not equal. I think this will just work. Let's try it. Awesome. We're good. So we were able to cut out a lot. So you can see we got the test to pass, and then we trimmed it down. So let's see, do we still need the equal? I think the equal is nice because it's an early exit, right? It prevents us from having to do that iteration, and it's just direct comparison. So why not? Let's do that. Let's have that there. We could add an else here and put this comparison unequal in the else, but maybe that'll make it more clear. Does that make it more readable? I don't know. Let's see. I guess it does, right? If it doesn't contain, it doesn't contain, it's unequal. I like that. It's kind of readable. Yeah, I think this works pretty well. The only thing I might do is, you know, like formatting wise, it might be nice to clean this up a little bit and just do like that. Although if I save, is it gonna just put it right back? No. Yeah, see, I like this. I would probably do it like this. Yeah. So I think that's pretty good. Let's run our test and let's see what other folks are doing. Let's submit it. So to do that, we're gonna do exorcism submit that up, and we could view our solution. So let's see how we did. So I'll go here, we'll go to exorcism, and let's just take a look. So refresh. On average, students that get mentor iterate a further 3.5 times in their solution. It's a great way to discover what you, oh, that's pretty cool. So we did pass, that's great. We did good. Let's see what other folks are doing. That's always fun, right? Okay, let's check out this one from 4 days ago. Whoa. Windows. Ah, I like this. Look at how nice this is. This is super cool. I love this because you know me, I love pattern matching. You know I do. You know I do. You've seen me do this. I love this. Check this out. Sublist comparison. So they're pulling in comparison, which is the, they're using it here, right? We're using that. They just cut out, they're basically saying, you know, just pull it all in so I don't have to say comparison : : I like that. It's a lot simpler. And they could just say superlist unequal sublist. That's beautiful. Now what they're doing is they're matching on the length of A and B. If they're 0, they know they're equal. If one is 0 and the other is whatever, we know it's a sublist, we know it's a superlist. And then here, they're grabbing the lengths and they're saying if one's greater than the other, check. If any of the windows, so if you look at any window of A, and if any of those windows, so it's going to look like this, 1, 2, 3, 4, 5, 6, it's actually going to go through each window. If any of them equal B, it's a superlist, otherwise it's unequal. And then they're doing the same thing here, but you know, in the opposite direction. This rules. I love this. Can we like this? I would like to like this. Let's write a comment. Love the use. Let's comment. Let's comment. Look at us. We're involved. We're involved. This is great. I really like this. We'll have to try to implement this. Super cool. And we can do it without our match. We can try using it. Let's try it out. So let's go here. Instead of doing this, just for now, let's say if, and we don't need our strings, right? So we can do if first list dot windows returns an iterator over all contiguous windows of length. So cool. And they're doing it of length, the length of the other list. Oh my God. This is so cool. All right. So first we do need to check the length. So we'll say if first list is greater than, we might still need our equal check, but let's just do this. If first list is greater than second list, right? Then we can do first list dot windows and it's second list dot len. And then what are they doing? They're checking if any of those windows equal it. That's really cool. So dot any, let's do the same thing here. We're shamelessly copying it, but that's cool. And we're checking if it equals second list. And we're basically like, so what we're doing is this is a check, right? So we're checking. So we're kind of like nesting the ifs here. So we're saying if that's the case, right, then we can return comparison Superlist. Otherwise it's unequal, right? We know. But we don't need to. We're going to return unequal at the end anyway, so we don't need to handle that right now. Here we'll do, and we can even, because we only have one condition, we can do something like this, right? Right? If first list is greater than second list, and we actually want len. And that's why they matched on len. I love that. It's super cool. Then windows, get rid of that, get rid of that. And then here we need to return comparison unequal, right? The other case is else if second list is greater than first list dot len. And we're going to basically copy this and just change it a little bit. So second list, first list, first list. And if that's the case, it's a sublist. Pretty cool. Let's try it out. Let's run it. All right, so we failed one, and I think it's probably the Superlist of empty, right? So that's just basically the empty check that we had. So for that, we can just add our conditionals here. That would just be like, you know, else if. Basically, we would check if this one's empty, it's a sublist of this. Otherwise, if this one's empty, it's a sublist of this. So we're going back to the if statements that we had, which is why I think this is more effective, is because you can get those checks right out of the bat without an if statement, because all this match is a big if statement. But pretty cool. Windows is a good option. I think it's a cool option. I would definitely want to go with something more like this. But yeah, we don't have to shamelessly copy that now. I kind of like our solution. I think it's pretty simple. I'm going to keep it as is. But pretty cool to see Windows. And yeah, let me know what you think in the comments. I think we did a pretty cool job. Let me just reset this. Wow. Go back. What do we have? Go back. That's back to the start there. Yeah. I mean, I think the window is definitely the way to go for sure. But this is pretty cool. I don't think we did too shabby. Awesome. So yeah, maybe next time we'll end it here today. Maybe we'll redo this next time, go over it, try out the match. But yeah, that's pretty much it for today. Thank you so much for watching. I hope you enjoyed this. It was kind of fun trying to think about different ways. It's always fun checking out the solutions, so that's always super cool. Again, if you missed the previous ones, don't worry. You can always find them here on the YouTube. Check them out. We went through all the other ones, Exorcism Part 1, 2, 3, 4, 5, and we'll continue with this. But yeah, I'm really enjoying it. Leave some comments. Let me know what you think. That match is super cool. Really impressed with that. You can also follow me on Exorcism, right? If you go to Exorcism, you can find me and find all my solutions. So do that. You can put some comments. That'd be awesome. I don't think we've gotten any comments yet, but I don't know. Maybe. So check it out. Looks like we have, that's the comment I left. But yeah, check it out. Leave some comments, whatever you like. Anyway, thank you so much for hanging out with me tonight. Again, doing some more of the exorcism.io courses, and we will continue doing this. I'll see you all next week. Thank you so much.